In this video, I'm going to go through how to use the Carve software to do the chocolate mold project for those of you who chose Unit 4 in this course. I'm running on the assumption you've already gone through and installed the Carve software and started going through and doing these tutorials at home. If you have not installed the trial software, like I said, or you haven't finished these videos, you need to do that and then come back and watch this video because I'm going to assume you know certain content. When we did our keychain project, I had it set up in the CNC router at the back of the class, and we used this cutter. This had a little bit of a sharp point on it, and that's the one we used to make the engraving of your keychain. For the chocolate mold project, we're going to use a different kind of cutter. It's called an end mill cutter, and it's basically no point. It's a square end, and the diameter we're choosing is 1/4 inch. So the one we have actually looks something like this at the back of the room in the CNC machine. So the diameter is 1/4 inch, and it's a square end, not a point like you've seen before. In the Carve software, I went in, I've already set it up to make the video faster, but basically I set it up as a 2-inch square for the chocolate mold project and 3/8 thick. Please make sure it's in the origin in inches. Do not do this. Don't put that dot down there. It's got to stay at the top. You can pick different materials. I think it defaults to a wood, but I always, for the aluminum projects, you can switch it to silver satin. I always try that one. But anyways, that's what I've already done. So again, when you're using Carve, the white square is the size of the material that you're assuming to use for your project work, whatever you want. Then when you draw your vector paths, you do that with all these different tools. And in this case, all I've done is put a simple oval in there. I want to leave an oval here. I want to shave off all this other stuff around and make it look, no, I lost it. I'll come back. Make it look like an oval island sitting on the top of this square table, in a sense. To do that, I'm going to do something called a pocket cut for my toolpath instead of the other one. So I'm going to go in here, and I've already made it up. In my pocket toolpath, I have 2 vector boundaries, the oval, and then I made this big rectangle outside. And I purposely left it long over here and short over here because I'm going to force it to do something by mistake that I didn't want it to do. When you're setting up your pocket for this project, keep that number at 0. Put that at 180 thousandths of an inch, 0.180 in inches. The tool that we're using, I've already selected it, but you can go in and select, but I'm going to go under Edit. And under Edit, I'm just showing you, when you select, you've got to make sure you pick the end mill. Make sure you've got the right one, that one with the flat bottom. And the D, the diameter, D is 0.25. You have to have that number right there. Okay, that's important. Pass depth, that kind of connects over here. See where it says passes, 3 passes? That will come up in a second when I do the simulation, but I can't let the cutter cut too deep each pass, each time it goes through, because it's too hard on the machine and it might break the cutter off or dull it up. So around 80, 85 thousandths of an inch is good. Step over it, leave that at 40%. It does a pass, then it moves over 40% of its own diameter, cuts again, 40% over, cuts again. That's kind of seems to work well without breaking cutters. Spindle speed, how fast will the cutter spin in the motor, in the machine? So the cutter will spin around 8,000 for that cutter in aluminum. That seems to work well for us. If I went too fast, it would probably break the cutter. If I went too slow, it probably overheats and stuff, if you can believe that. Feed rate, how fast it moves around in X and Y while it's cutting, so 50. Plunge rate, how fast it comes down when it starts the cuts at 10. So we'll leave those numbers. Please, 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 please make sure you have these numbers correct. Okay? So I'm going to leave that as okay. Ignore that background. So you select your cutter, leave all the other settings, and then down here, make sure you call your toolpath a name that makes sense. So I'm calling mine the outer step, and then I hit calculate. You'll see in the simulation the path that the cutter will take. I set the speed a little slower just so you can watch what's going to happen, and I press play. It's going down 85 thousandths. Remember the first pass step? That's how deep it's going. Does the first pass. Now it's going a bit deeper. It's going to cut again the second path. Goes around. Some of you are already noticing, uh-oh, what's going on over there? Something's not looking right. Here's my third pass. So it's cutting through another 85 thousandths of an inch. And that's the last cut. And then I'm done. Now you can see, if I look, if I look over here, that's beautiful. That's what I wanted. I get all this stuff out of the way. There's my oval island. And the cutter went through. But what happened over here? How come it didn't go through here? Well, if you look over here, some of you, I'm going to zoom in here. There's not enough room in here. Remember, a pocket cut, it cuts between two vector lines. So I'm saying between this line and this line, cut everything in between, cut it all out, cut everything all the way through. That's what a pocket cut is. So you're saying, oh, go in here and between this line and this line, cut this out. But there's not enough space in there. Watch this little trick in case you're having trouble. I'm going to draw a circle that's diameter is 1/4 of an inch because that's the diameter of my cutter. If I go in here and say that circle, oops, I think I clicked it twice, sorry. That circle is a 1/4 inch diameter. So if I pretend that's my cutter's going around, zing, 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 and then you're asking the computer, go in here, and it goes, can't go around there. So if you look over here, oops, okay, got in trouble here. If you go over here with the cutter, if you pretend, okay, well, look, I'm actually I've got it too big. I could probably bring this in and bring it in closer and say, you know what, the cutter will still zing through there. But on the other hand, I got to bring this one out. And I need to go out enough to make sure that my 1/4 inch diameter cutter can go through. Oops, still not enough. See that? So I'm going to do this. Let me zoom in here. I'm going to do, I got mouse problems today. I'm going to go in here and I'll stretch that out a bit more. So, okay, now I should be okay. Now I don't need this cutter, so I can just delete that. I'm just doing it to help me understand what's happening. Zoom to fit, go back in. I'm going to recalculate, reset, and I let it rip. And now you notice how it's cutting on both sides of my oval. And I should be able to get, yeah, see now it's going to work. I get a simulation that works. And when I'm done, I can actually speed this up. It'll go a lot faster. Boom, there's my first step, or my first stage of my chocolate mold, and I get what I need. Next good question, and I see this a lot when students are doing it. What would happen if I did this? Like really, why don't I just do that? Oops, sorry, that's not what I meant to do. Why don't I just do this? You need space? Give me space, baby. Open it up. Who cares? Well, you do care. Because if I do that, and then I recalculate, look at what it's doing. It's basically going to go in, and it's going to say, okay, well, you want to cut between that path and that path? So the cutter will go along in the machine and we go along, and I always joke with the students who make this mistake. You're just cutting air. You're sending the cutter around and there's nothing there to cut because your aluminum piece is only this big and you're sending the cutter out on these XY coordinates way out here, and it just kills time. So if you look here, there's this clock feature. I can't remember if I said it in the other videos, but you can go in and say, okay, how long is this going to take to cut? And right here, it's going to take 10 minutes, 10 and a half minutes to cut it. However, if I go back here and say, look, I don't have time to go out in La La Land cutting everywhere. If I bring this in a bit closer and make this a bit smaller, then I'm not wasting machining time cutting all over the place. And then I calculate, reset. It looks like it's going to work. Yeah, I got the distance right, so the cutter can sneak through there. And I get the shape that I want. And then my cut time dropped almost to half that, less than 6 minutes. So that's kind of important, checking your cut times when you're doing it. Okay, so that's the first part of the video, making a basic pocket cut so you have an island. Again, for your design and your chocolate mold, doesn't have to be oval. I've had some wonky designs, stop signs, hexagons, wigglies, anything. You could do that. I've had students, pardon me, I've had students who want to go farther, level 4 kind of stuff. Right now I have one step, right? This flat goes up, step up, and then I'm on the flat. And some of them have actually had 2 steps, 3 steps, kind of like a wedding cake idea. You could do that as well. And when you come into the classroom, I did cut one on the machine that has multiple steps. I'm not going to tell you how to do it, but that would be your thinking. How would I make multiple steps of that if I wanted to? This is just a very basic one. I'll leave that to your design. If you want a level 3, make a simple step like this. You want level 4, multi-step wedding cake idea. In the next video, I'm going to show how to make something else on this step. I'm going to shave this step off and leave a logo or design on here. So that's for the next video though. That's it. Give it a try.